There we go. And then D says write a bound for square root of x to 3 significant figures. So we said for part C that was 3.81, right? So we rounded here, correct? So for x, the biggest that could be would have been 3.8. And if it was any bigger than 0.5, we would have rounded that, 1.5, we'd have rounded it up, correct? So I'm going to use the strict less than, so that count as like, 3.8149999, like I want to get it as close as I can. And then the lower bound would have been, bless you, that, right? Because that's the smallest it could have been to round up to 381, right? It could have been 380.5 or 3805, and then anything bigger than that, we're going to round up all the way to 381.5. Will all get rounded to 3.81.
Okay.
Is that?
Yeah.
That feels okay? All right. And you also wanted to talk about 4. Did you say 4?
Yeah.
Okay. And if anybody else has ones that are like ready to go, like sock it to me, get them ready. We're just going to crank out some homework questions here. 4 says, find the largest percent error for each quantity. A measurement of 23 kilograms, correct to the nearest 1 kilogram. Okay. So what we're going to be saying here is like x was equal to 23. But what was the bound on that? That could have been like 22.5 all the way up to 23.5, right? So either end of this is going to be the same thing, right? If I look at the percent error, they're going to both give you the same error because they're both half a unit away from 23. So it doesn't matter which one I take. I'll just take that end because that's a number that actually exists. So if that was the exact value and 23 was the estimate, the most we could have been, or the biggest error that we would have had would have been, we could probably write a calculator program to just like do exact input that and the approximate input that and then just press enter. That might save us some hassle. So 2.22% approximately would be our maximum error. Did you get what to do with this from now?
Yeah, I didn't know you had to do that.
Yeah, that's what you would have needed.
Okay.
So like that's the biggest error that you could have had on that measurement would have just been the half unit from rounding. Okay. Cool, dude. And you don't need to do the rest of them after this point, right? Because it's all the same, basically. Okay. In fact, probably the rest of them where they give you 2 measurements, you knew what to do with. It's probably just that first one that you're like, what? Yeah, sure. Absolutely. Okay. It says the diagonal D of a rectangle with length L and width W is given by Pythagoras' theorem. D is equal to square root of L squared plus W squared. We recognize this as the Pythagorean theorem where we just like square rooted both sides of the equation, right? And then use D, L, and W instead of C squared, A squared, and B squared. Or C, A, and B. All right. It says a rectangle has length 18 and width 10, both correct to the nearest centimeter. Calculate D to 3 significant figures. How many significant figures would be appropriate for this calculation? Okay, well, let's do the first part of that. So square root 18 squared plus 10 squared. And that comes out to be 20.6, rounded to 3 significant figures. From your science class, do you remember what the criteria is for rounding with significant figures? Just look at this real quick. Okay, so it's going to be based on your measurements. So we should be rounding this to the nearest centimeter because that's what our measurements were rounded to. So this should probably be rounded to 2 significant figures to 21 centimeters. Does that track with you guys? Since the other measurements we used in the calculation were rounded to the centimeter, our answer, the most accurate it could be, is to the centimeter. So that's where the rounding should happen, which would give us 2 sig figs at 21 centimeters. Find the difference between the maximum and minimum lengths of the diagonal D. So here, the maximum L would have been like 18.5, and W could have been at most 10.5. And the minimum that the length could have been would have been 17.5, and the width 9.5. So go ahead and calculate D for each of those, and then compare how much different they are. So I'll just do that on my calculator. Sadeki, who are you going to share your snacks with this year? All your snack buddies are gone. Is it just good for you, like more snacks for me?
I'm sure you do.
I brought my own snacks, you know. But thank you, I appreciate the offer. At least today I have my own snacks. So I just calculated the D for each of those situations and looked at the difference. So I get about, 1.4 centimeters or something. Or actually 1.36, 3 sig figs probably. An estimate of D is given as 20 centimeters, and the exact value is the maximum found in A, correct to 3 significant figures. Find the percentage error of the estimate. Is the maximum found in A? We didn't find a maximum in A. I don't know if that's, I don't know whether they mean to use your answer from the maximum B or to use your answer from A. So I'm not really sure what, but either way, you're just going to take one of those two answers and then do a percent error on it. This seems unclear. I think likely there's a typo in there, but you get the gist of it by now, I think, right? Swell. What else, guys? 8? Sure. This one came with a picture. Ooh, fancy. It says a cuboid has a length of 0.89 meters, correct to the nearest hundredth, a width of 2.1, correct to the nearest tenth, and a height of 2, correct to the nearest ones. Write bounds for the length, width, and height. Okay. So my length was 0.89. So that at its smallest could have been 0.885. And the biggest that could have been would have been 0.895. And then the width is to the 10th. So the smallest that could have been is 2.05. And the biggest that could have been is 2.15. And then my height was 2, so the smallest that could have been is 0.15, and the biggest it could have been is 2.5. Okay, there. B says write a bound for the volume of the cuboid. Well, what I would probably just do here is I would say, well, the minimum volume would be if all of those are true. So that would multiply those three together. That's my minimum. Multiply those three together. That would be my maximum. That's what I would think that it would want us to do. Right? The smallest volume is going to come from the smallest measurements. So there's, again, I'd probably round those to 3 sig figs or something, but those are the bounds for my volume. C says estimate the volume of the cuboid and calculate the percent error between your estimate and the dimensions given. Yeah, let me read that one more time. Estimate the volume V of the cuboid, okay, and calculate the percent error between your estimate and the dimensions given. Okay, yeah, that's, I guess, this way I would read that. The cube is made from granite, which costs a lot of money per cubic meter. I guess a cubic meter is a ton of granite, though, so I guess that's fine. Find a bound for the total cost of the cuboid reported to an appropriate level of accuracy. So again, my bound would be then this number, the smallest possible volume times the 150. That's the lower bound. And then my upper is going to be the largest volume times that 150. So that's the bound on my costs. Does that feel pretty good?
You don't include meters in this, just
I don't include the meters in this. Oh, that's, oh, yeah. So the unit on this is just going to be dollars, right? Because we multiplied cubic units by dollars per cubic unit. So the cubic units cancel out and you're left with just dollars, right? So those are both monies, the $410 and the $725. And I'd probably round that to the penny since we're talking about money, regardless of the significant figures involved. How do you guys feeling? You want to do this quiz? No? Well, here's the thing. If you want to do it Friday, we're going to do the quiz and the test then back to back because we'll have finished the chapter. You want to do them on the same day?
Wait, the test is Friday?
No. But like, well, I guess we would do the review day and the quiz on the same thing, on the same day. That's fine. I don't care.
Oh, yeah.
Yeah, I mean, we've been doing the stuff. You don't have to have anything memorized. Really?
It's not
So you'll need your calculator, right, for sure. Sure. Yeah, let me pass them out and I'll grab you some loaners. Uh-oh.
Recommend changes that.
You got the rechargeable, you got like old school batteries.
Old school.
Yeah, you can get some AAAs there for me. Yeah, but like the questions are like shorties. Yeah. It's like rewrite the number, rounded to the hundreds or something, you know, like. Yep.
One, two, three, one, two, three. Right, so. Well, 30.
The major, dude.
Yeah. Just so you know that I have
Oh, I thought you.
4 calculators. So this is I passed out all the calculators I have. Those of you that do have calculators, try to remember to bring one. Because there's one more person forgets, we're not in trouble.
My calculator. Do we just mark it? It's like a check. Letter.
Oh, yeah, check is fine. Yeah, like if you're saying yes, then like -5 pi is the natural number, put a check mark in that column. You know what I'm saying?